host Pranami Bharali. So I'm an architect and a BIM specialist here at Capricorn. So I'll be hosting the session today. So before moving this forward, I would like to thank each and everyone here to taking out the time and joining us here for the online workshop. So let me just go you through the program details. So today with us, we have architect Vatsal Singhal and architect Varappam from Capricorn itself. Both are BIM specialists here. So they will be doing the session for the QTO today. So during the entire session, we'll be keeping the Q&A open so that you can post your questions and we will be taking the questions at the end of the sessions. Okay. So the Q&A sessions are always open, so you can post your questions. So, and last we'll be taking through the BIM for Design course and the BIM Guru course that we have here in Capricorn. Okay, so before moving this forward, so let me just give you a little brief about our company. So Capricorn is India's leading design and construction management technology solution. So for architecture, engineering, and construction industry. So we serve more than 20,000 plus Indian customers, and we have 40 plus BIM experts here. So so Capricorn has become a Win0 company and a global company now. So it's an amalgamation of US CAD in USA. Then we have CAD line from United Kingdom and Capricorn from New Delhi and A2K from Australia. So this four company has come together to merge to become a Win0 company. So today we'll be starting with the session then. So I hope Vatsal, are you here? Uh,
Okay, hello everyone.
yes. So Vatsal, over to you then. Just give us a moment. He's sharing his screen.
Okay, so good afternoon everyone. Myself, Vatsal Singhal, architect Vatsal Singhal. So I work as a BIM specialist here in Capricorn Technologies. Today we will be going through the process of generating basically the quantity part from the Revit, and also after that we'll go through how we can link those quantities to Dynamo that Varapam would be taking. So I'll just take you through the short PPT first. In this PPT, we'll basically discuss about the overview of Revit, and after that, we'll discuss how we take the quantity takeoff here in Revit. So quantity takeoff is one of the most crucial parts. Just a second. Quantity takeoff is one of the most crucial parts of the design and construction of a built environment. For effective project delivery, the construction industry is shifting from manual calculation of quantity takeoffs to the BIM model based real-time automated quantity takeoffs. This the reason, major reason because of this is as one of the repercussions of the pandemic area, working from home culture has evolved a lot, and because of that, effective work from home can only be possible with proper technology and tools. A lot of companies already have adopted the technology already. Suppose banks, they are already up to date with the technology, but we in the AC industry, we also need to like update our technology and bring it online and like make everything automated for our convenience basically. So for that, quantity takeoff in Revit is like a major part of Revit. So we'll move on to that. So the intent over here is, so for the design consultants, the contractors, the quantity surveyors, so that they adopt more towards BIM and improve it. Since it gives us accuracy, it increases the time efficiency, and it also helps us develop the skill to generate the quantity takeoffs. So the major topics for today would be the Revit overview and the advantages of Revit for all those who are new to Revit, so that they understand how Revit helps us through this. Then how we manage the Revit families for accurate quantification, and then we'll go through the live process, how to develop quantities and extract the materials and everything from Revit. Then after that, we open to questions. In the quantification part, we'll also teach you how to link the quantities to Dynamo. I'll take you to the Revit overview. So first of all, what all does Revit gives us? So it totally gives us a coordinated model. Suppose a lot of technical people work on a single. So a lot of technical people basically work on this. uh, Suppose there are structural engineers, and then we have uh, the MEP people, then we have architects. So all three teams, four teams need to coordinate together to bring up a single model. It is very consistent. Then everything is computable over here. You don't need to compute everything manually. It is automated, auto generated, as we are talking about here in the quantities part. Then everything is like clear. There's a proper continuity to everything. It's agile, so everything in Revit and the BIM process is very like consistent, and with a proper flow you work on it. So a lot of people, as I said, together work on it to develop a multidisciplinary model. As like the electrical services model is there, then you have the structural model that comprises of all the like beams, columns, foundations, slabs, all the details of the structure. Then the interior part on what all the furniture part is there. Then the landscape consultant would work totally on the landscape part. He will develop the landscape model. Then mechanical services model would be all the mechanical services like the HVAC part, plumbing part. Then exterior architectural model would be there, how the building would look from the exterior part. And the prefab model, in case you're working on a prefab project, there would also be prefab model to show you all the connections and all the details of that. All of these would combine and make a multidisciplinary model for that. How it works, a lot of things can be done in Revit. So there's a central model that we work on. Apart from that, we develop different types of drawings, maybe electrical, structural, piping, lighting. We develop BOQs. We get automated sections. We don't need to cut sections everywhere. Like suppose you work in AutoCAD, so you have to develop sections for each and everything individually. Here, you just develop a central model, and from that section, you can cut the sections from anywhere you want. You get 3D sections, you get proper elevations of that, you get all the carpentry details, all the plans. So there's a single coordinate model that provides you with everything all together. Hello. Okay. So when can you work on it? We start from the conceptual design. Then we go to the main design stage. We go to the detailing part, the fabrication part. So at every stage, Revit or the BIM process helps you in developing the model. Then you have the pre-construction phase, the field execution, the operations. After the building has been made, everything has been constructed, it also helps you to help in the operations part, how the energy analysis would be done, how the O&M managers can like work on that particular building or particular type of project. So it will help you all together in everything from the basics to the end, and even after the building has been constructed, the operations would be like flawless with this process. So the types of projects that it can handle, the data center projects. This is a data center project which has like all the mechanical details, the electrical details. It has all the server rooms and everything. So this is a project that can be done on Revit. It's a very vast project. If we say a data center is not a like easy project, a lot of services are there. They need to be included in a model, so it takes a lot of like time and effort to do this, but this makes it very easy to like work on the site as well as develop it, as well as you got get all the like problems that you might face while building the project. So you can work on these kind of projects. You can work on a commercial project totally. Suppose there are offices, buildings, mixed use projects. Every type of project can be worked on. Then you have institutional projects. Institutional projects like you have colleges or any of the buildings, schools, primary schools, anything can be done on Revit. Other type of projects are the infrastructure projects where you need to develop the roads, bridges, and then you need to develop the canals or anything. These all also are like easily capable of doing in Revit, everything over here. Urban design projects, big scale project where you need to develop proper landscape, develop the roads, you need to develop all the mechanical details of that project. These type of projects can also be done in the Revit part. Then apart from that, you have industry projects, you have factories or other types of mills or anything that also can be done in Revit. So these basically show how you get the quantities for this. This is a small example for that, how the quantities can be developed from this. So we have a single coordinated model from which we can develop everything. Here, as you can see on my screen, this is a 3D model that has, this is a basically a sample project developed by Autodesk. So in this, if you see, this is a 3D model. From it, we have all the plans, we have all the details of the sections and the elevations. So concurrently designed and documented, proper documented drawings are available. Single coordinated database is there. You don't need to develop different kind of databases for this. You can instantly generate schedules, drawings, sheets, 2D views and 3D views. The basic function over here is you don't need to do anything separately. Usually what people do, what we do in projects is we develop the plan first, then we make the 3D model, then we develop sections, then we develop elevations. But here you're working on a single coordinated model that helps you in developing everything just on the go. Just on a click, you can develop everything. You don't need to do it separately for each and everything. So a major part of this is clash detection also, where you basically construct the building already. This is a virtual building that you construct in Revit, and on site a lot of clashes can be there. Suppose we talk about over here is this HVAC pipe that is passing through the beam, so it is already detected, so we can like work on it. This is MEP model, then this is a structure model. So when we detect the clashes between the two, we found out that there is this HVAC duct that is coming through the beams. So this can be resolved before it is like on site. This problem is faced on site. You beforehand develop this mistake and work on it. So there are a number of clashes that you get. You can go on to each clash and work on it separately and resolve it, so that when you release the GFC drawings or when you actually construct the building on the site, you don't face these problems over there. Another thing over here is the change management. Whenever you wish to change anything in Revit, it is automatically updated everywhere. It reduces and minimizes the errors and the omissions. So I'll just go back. So if I see, just a minute.
full screen view of the building.
Okay, so here, if you talk about the change management or the revision updated automatically part, is if you change anything over here, suppose, so it will automatically be updated in the plan as well as in the section or in the elevation. Everywhere it will be updated. You don't need to like go to every other drawing or every other sheet to update it. It would be automatically updated everywhere. So we also talk about the design and visuality part. Here, if you see for the visibility part, we have the 3D part over here. We can get develop realistic views. These are not rendered views. These are just realistic views from Revit. So you can beforehand see before making any renders or anything, you can see how the lighting would be there, how that space would look after being built. So there are different types of views that you can work on Revit. And then you can also render this. You have the render in cloud option, you have the render in Revit option. And as you people might know, now we also have the twin motion part over here. So we can also take the drawings directly to twin motion, link them, and render it on twin motion too. So there are a lot of things that can be done even in the visualization part. Also, there's the walkthrough tool in Revit. You can develop the walkthroughs for your like requirement or the ease of developing the space or understanding the space. Simple walkthroughs can be developed over here. It also enhances the documentation quality. So manage changes in the model throughout the documentation process. If you see over here, this is a model, this is a 3D model of a space. After that, you have the sections over here, the section over here. Then this is the 3D section that has been cut over here, that also is available. And then you have the plans. So everything here is available on a single database, single Revit, and is a single coordinated model for all the drawings. Then you can even develop different details from that. It will really help you a lot in developing the details. So basically, it's just a consistent representation of a building. It also reduces the error because here you don't have to work on everything individually. You work on a single model and everything is updated. So the chances of errors is like minimized. So that's about the documentation quality of Revit. It also minimizes the cost of changes and manual coordination, since you already know what the problems will be when you like construct the building on the site. So that will also minimize the cost and changes, because usually what happens is you go to the site and changes happen there and there over here. So but here you already know through a virtual model all the problems and everything that you might face on site. So you can minimize the cost of changes and the manual coordination. Since since everything is automated, so manual coordination is like reduced. You know that your documentation is coordinated and up to date. So that is what will help you reduce the manual coordination and the cost. Along with Revit, you get extensive content library for the 2D and 3D real world building elements. You also get a lot of materials here in Revit that you can like apply to your building or anywhere uh, around that. So you can just take these models, apply it on Revit and use it for that 3D purpose, or even the 2D annotations part can be developed in Revit itself. When we talk about the Revit families, now we have different Revit families. So there is a loadable family, then there's a system family, and there is the in-place family. So the loadable families are whatever we load from outside in Revit, the columns or the beams. The system families are not loadable families that these you don't need to load in Revit. You get them by default. Suppose there are floors or the walls. There are the types of walls over here. So you can develop them in Revit itself. You don't need to load them. And in place families are whatever you need to develop in like in spite of the loadable family and the system family. There's particularly some customized thing that you want in Revit and it can't be loaded or is available through the system family. So that thing can be made through the in place families. Suppose I talked about the loadable family. So the columns and beams are a loadable family. The wall is an example of the system family. Wall will be like different according to different projects. So that's how the wall works. And in place family, an example for this is this, there is this column and this is this piece of furniture or this table was required over here. So we drew it, we made it through the in place families according to the requirement, as this would not be available in the loadable family and system family. So we have to develop it through the in place families. So any type of mass, any type of shape can be developed through the in place families. There's nothing that cannot be done in Revit. Hierarchy of Revit families. So in the hierarchy, we have the Revit family, we have the components, we have the discipline, then we have the categories, we have the families, and then we have the type. So when we talk about discipline, it is the different disciplines of a project. It can be architecture, or it could be structure, or could be mechanical. So there are different disciplines available here. Then we have different categories divided on the basis of the functions. Categories, as I explained, walls are there, windows are there, columns. Then the family is divided on the basis of component shape. From the wall, we have different types of wall. We have the basic wall, the curtain wall, the stack wall. Curtain walls in Revit are basically the glass walls that we talk about. And then in the type, we can create different types of wall from this. The basic wall, we have 115 wall or the 230 wall. Revit family examples. This is a family example where you can like justify the heights, you can justify the offsets and everything here in Revit. Now we'll directly come to the quantification part through Revit. So you can like extract quantities easily. Soil cut and fill schedules can be generated, footing informations, the material takeoff. Suppose there's a wall, you have the plaster layer, then you have the paint layer. Or if you're working on any sort of auditorium or a studio, you have different layers of the wall, you have the gypsum, you have other wall elements that are used for the soundproof system. So you need to also calculate the quantities of that. So for that, we have the material takeoff. Then you have the structural information input, where you can extract out all the structural information, the architectural component input, whatever the architectural components are available in this, and the material takeoff also. So different things can be like generated from Revit. Different types of quantities can be generated in Revit, and will help you a lot to work further, as these would be like very accurate in the calculation part. You can also develop the quantities phase wise. Suppose there's a project that we work on is phase wise. There are like 4 phases. So according to the phases, the cost might vary, the quantity might vary, as the as we work on the site. Different types of like problems are occurred, and after that you need to make small changes or anything. According to that phase wise, the material also like expands or decreases, whatever the case might be. So phase wide material quantities can also be extracted according to the cost and the time. Bar bending schedules, for that you need to develop the rebar details first. You can also develop the bar bending schedules after that. All the rebarring, all the steel structure and everything can be done, and after that you can take out the quantities, or even if it's the weight of the rebar part, that also can be like extracted from here and can be easily calculated. So as we generate automatically the schedules part, it improves the visibility of cost and quantities. It is the comprehensive view of the latest BIM data that we have developed in our model. The changes are reflected automatically in all views, including the schedules. Suppose there's a column that you have to remove, so it would like instantly be removed from the schedule as well. You don't need to update the schedule and again and again. So all the changes reflected in the model will also be updated in the schedule. So there are different types of schedules in Revit. I'll just explain these to you. So we have the basic schedules and quantities, which helps us in calculating the schedule of building components over here. All the components like beams, columns, walls, slabs, these can be calculated from the schedules and quantities. Then you have the graphical column schedule that will help you see the column shape according to different floors and understand how the column is acting on different floors. That will help in generating the column part on site so that no errors are faced over there. You get to know how the column is decreasing or increasing on different floors. That can be done through the graphical column schedule. Then you have the material takeoff. Material takeoff basically helps you to like calculate the materials of the subcomponents. This suppose in the schedules and quantities you calculate the quantity of a wall, and there are different layers in the wall. So through material takeoff you'll be able to calculate those different layers of the materials. So that is the difference between schedules and quantities and the material takeoff. You can also generate the sheet list for transmittals or different uses according to the project. So a schedule of all the drawings in the project, the date, and the particular person who has developed those sheets or worked on that. Everything can be developed from here. The node block, schedule of annotation symbols, the 2D components. There are different 2D components in a project. The schedules of that can be created too. There are different views in a project. A view list of those can also be generated from the schedules. But here today we'll only be focusing on the graphical column schedule, the material takeoff, and the schedules and quantities. So these will be the three major topics that we'll be covering in the quantification today. So I'll just take you to a live project on demo. Just give me 2 minutes. Okay, so I hope my Revit screen is visible. So this is a small model for which we'll use the schedules and we'll create the schedules of this. We'll see the difference between materials and the basic schedules. So for schedules, there are two places from where you can generate schedules. You can go to the view tab. and here you get the schedules option where you'll get all these 6 type of schedules. Apart from that, in the project browser also there's an option to generate the schedules. So if you just right click over here, you'll again get to see all these options over here. So these are the two places from where you can generate the schedules. So if we see, there are like structural components also available in this model. If I filter them and I just show you the columns and the flows. So just a second. So I'll just take you to the columns part. We'll generate a basic schedule of the column. So I'll just right click over here. I'll go to new schedules and quantities. Here you get different disciplines. You have the structure, architecture, mechanical, electrical, piping. So as I like open all of them, these categories would increase and you can select any one of them. But right now we can just select the architecture and structure, or maybe just the structure since we are developing the schedule for the structure part, structural columns part. So I'll find the structural columns over here. Here the structural columns are. I can just select it and I press OK. After that, we get different available fields over here. We can select any fields from here. So the major fields that we require are the family and type. Then we require the count of the columns. Then after that, we also require the length, or we also require the volume. Then we can also take the base level and the top level. So these are some of the options that you can take. From here, you can like adjust these according to the requirements. So suppose here the count is, after that the length is, I want length at the top. So you can control this from here. So you can include these directly from here and you can just click on OK after that. So this is the basic schedule of the column that we have generated. So as you can see, there are different lengths over here. Two types of lengths are there, 3000 and 3450. So if I take you to the elevation part, so this is the front elevation. If I measure these heights from here, so as you can see, this is 3500. This is rounded off, but it's the level is 450, and this is 3000. So according to these, there are two type of columns over here in the schedules. So there is a length of 3450 and there is a length of 3000. So as you can see, these are all the columns that are available in the project. So if I like apply one more column over here, so you'll see it will be directly applied from here. So I'll just go to the structure tab. I'll take a column. Okay, this would be okay. And I'll take a height of to the terrace level. And I'll just like place this column over here. If I go to 3D. So here this column is placed. Now if I go to the quantities again, here you will see there's another column that is added. The length here is 6450. So as I placed a column over here, it was directly updated in the structural column schedule 2. So that's how the live link over works here. If I select this column, I have this option over here in highlight the model. So if I click on highlight in model, so it would directly highlight the model in different views. Right now it's an elevation view. It will take you to the 3D view or the plan view. So that's how it works. You can highlight the model anywhere, highlight the component in the model anywhere through that option. I'll just go to 3D and I'll delete it since it's of no use. This was just to show you how you can see it directly from the schedule. After that, you have different options over here. If you want to suppose hide any of the co- columns that you have added, you can just directly go to the hide option from here. Apart from that, if you want to add any fields, So here you'll get all the fields. You've left out any field, so you can add it over here or you can remove it. I'll remove the count, suppose. So it would be removed from here too. So you get the option over here. It's not like you have once updated it, so it can't be done again. So you can use the field option anytime and update your schedules. Apart from that, we have the sorting and grouping option first. Let's just go through this. So suppose I want to, let me just add one more field over here. Okay, fine. I was looking for the level part, but I've already updated it. So I'll just go to the sorting and grouping. Now I want to sort these through the base level. I want to see all the columns that are available on NGL, or suppose I want to see the columns that are just of 3450 or 3000. Suppose I want to segregate these since these are all coming together. So we have the sorting and grouping option over here for that. From that, we can just sort by whatever you want to sort. Suppose I want to sort them through the length, since there are two different types of length. So I'll just take the length option and do OK. So as you can see now, these are like updated together, and apart from that, the ones that were 3.45 meters are updated together. Now we have different options over here. Suppose you want a header for that, I'll just place the header and do OK. So all the columns with the 3 meter height and the 3.45 meter height are segregated. Then one more option is you want a blank line between these two. So you can just take the blank line and do OK. So there will also be a blank line that would help you justify more of this. Now, if you want the count of the columns, so for that you can also take the footer, and from here you can take the count and totals only. So I'll just take the count and totals and I'll do OK. So there will be a total shown over here. These are 6 columns of this length and these are like 12 columns of this length. Like this, the sorting and grouping also works. Now suppose these are like 6 columns, you want to see them together, you want to calculate it together. So you can again go to the sorting and grouping option and you can check this off, itemize every instance option. After you do that, this will be created as one. Total volume would be there, and the length of each column was 3000. This is 3450. So this can also be done, though this is not that relevant, but this is also an option that you have over here in sorting and grouping. I'll just check this on again. I'll do OK. Now for a schedule, you only want columns that are of 3.45 meters height, and you don't want these. So for that, you'll have to filter these. So to filter it, we have the option of filter over here. We can filter it through different properties. So I want to filter it through length. So I can use the length option. Length that is equal to suppose 3450, and I do OK. So only the column that were of 3.45 meters height would be updated over here. Rest the columns that were of 3 meters height are removed, and only the ones of 3.45 meters are here. Now, if you want to filter it further, you can even filter it further. There are like columns of 200 by 300 also over here. So you want the columns of 200 by 450 only. So you can filter it further. You can then filter it further by family and type equals to family and type. That is equal to these two types of columns here. So I only want 200 by 450. So I'll select 200 by 450 and I'll do OK. So only the columns that were of this family and this type are updated. Rest all of them are removed. Right. After that, you have the option of formatting. So you go to formatting, and here in formatting, you have different options of family and type, length, volume, base level, top level. So suppose I want to calculate the total volume of these. So I can just go to volume and I have the calculate totals option over here. So I'll just click on calculate totals and I'll do okay. Now the the totals are calculated for this. It is 2.88 meters cube. Now also if you want to write something, you suppose you want to see the grand total option over here. So in the sorting and grouping part, you have the grand totals. You can customize it accordingly. Suppose I want this in capital, so I can make it in capital and I'll do okay. So grand total is also calculated. Now, if you're seeing this two times, so for that you'll have to obviously turn off the footer. Uh, then this will be only shown as one. The grand total, the count is 10, and the total volume here is 2.88 meters. Obviously, you won't require the length. This would only be required. Suppose it's a wall or anything. That time you will be requiring the total length. So you can also calculate that if required. Suppose I show you as an example. When I go to formatting and I check the length and I do the calculate totals option from here and I do okay. So the total length of this is calculated. There are 10 columns, so directly it's multiplied by 10, and it is 34500. That's how you can calculate totals over here. Now you can see all columns that are going from NGL to first floor of 3.4 meters height, 3.45 meters height are here of this like length and depth. So that's how you can like apply filters or sort the columns, use the sorting and grouping options from here. Apart from that, if we just go to the plan, we also have different types of walls over here. So if I go to the plan, the ground floor plan. So if I just select this wall and select this wall and I go to the edit type option, and I see there are different layers of this wall over here. The thickness is there, the plywood is there, then there's a structure of 100 mm, then you have asphalt and plywood over here. So different layers are available over here. Different materials are available over here. So you need to calculate the materials differently for each wall. I'll just do okay. So I'll just show you the difference between material takeoff and the schedules and quantities. So again, I'll go to the schedules and quantities option. I'll generate a new schedule first. I'm taking a normal schedule. I'm not going to the material takeoff right now. So I'll just go to the architecture. I'll turn off structure and I'll go to walls. So from walls, again, I have different options over here. So I can take the area. I can take the family and type. Then I have the length of the wall. I have the function. If you mention the function, it's interior or exterior. Then after that, you also have different options like top width, top offset is there. Then you have the width option. You have the width option, you have the volume option, you also have the height option over here. Okay, the height option is not here. So I can take the unconnected height option or just the just a minute. I'll just take the unconnected height option. Now I can like arrange it accordingly. I'll take the family and type, then I'll take the function. Okay, I've already taken the length, sorry. So I can also bring down the area. So I have the family and type, I have the function, length, width, area, and the volume. So I'll just do okay. So all the walls that were available in the project are here. Now, if we see, we have a different wooden partition, like this wooden partition that we were talking about right now. You also have the plaster that you applied and different options. You also see the function, all of them are exterior. You can change it to interior accordingly. The width of all walls is over here. The length of all walls is over here. So I can now like just filter the wooden partition. So I'll just filter, I'll go to family and type. and I'll just take the wooden partition from there. So these are the wooden partitions that are available. If you see, only the family and type is there, function, length, width, area, and volume. You can't justify the materials over here. Even if I go to the fields, there are no materials. There would just be a structural material that is here. The structure material, if I update it over here. So the structural material for the walls is here. Nothing apart from that is here. There were different materials of gypsum, asphalt, and others. So none of those are over here. But I also require the area of that or the width of that. So for that, we require the material takeoffs. So let's just take out the material takeoff once. Generate the material takeoff. So I'll take the new material takeoff now. So for the material takeoff, again in the architecture tab, I'll just go to the walls. Okay. And now if you see in the material part, now you have different materials over here. You have the material area, you have the material cost. If you know the cost, you can get into the cost too. After that, you have the material volume, you have the material unit weight, and you have the material name that would be required. Then you have the width. We'll take the family and type, and the areas. The area, this would be the total area, and this would be the area of the material. So we don't require this, I guess. And we have the length. So I guess this is all that we need for now. Also the volume. Oh, we've taken the volume already. So we can adjust it accordingly. Now, after that, we'll require the material name, material area, the material volume, width, and length. So I can just create a schedule. Now, all the materials of all walls that are present in the project are over here. So we just need to see what the wooden partition was there, different materials of the wooden partition were there. So again, we'll filter it over here, and we'll filter it by family and type, and we'll just take the wooden partition. So in wooden partition, as we saw, there were different materials. So all these materials have been applied over here. There is paint, there is plywood, and other materials that were here are also there. So you can also now sort them accordingly, according to the material name. So I'll just go to sorting and grouping, and I'll take the material name, and as header, I'll take it. And okay. So the asphalt, the paint, the plaster white, the plywood side, 7 ply, everything is here. But as you might have seen, if I go to the, let me just close these first. If I go to the ground floor plan, I select this wall and I go to the edit type. So here there is no like paint option, the plaster option that you just saw over here in the material takeoff. There is no plaster white available in that. Just a second. So I'll just select it and I'll show you again. If I go to the edit type, there is no plaster white over here. So why is that visible over here? The reason for this is since it has a property of paint applied over here. So if I go to like, I'll isolate this option and I see here. So here there is this plaster paint that is available in this material takeoff, white material takeoff. So I go to 3D. So this is applied through the split wall option, like the split face option here in the modify tab. So if I want to apply a different material again, so you have this option over here, the split face option. You can just select a face and split it accordingly. So suppose I'll just show you how it's done. So I splitted this face. Now I can again apply paint on this. So here you also have the paint option. If you go, so the shortcut to paint is PT, or you can directly select it from here. I'll just apply a different type of paint. Suppose this parking stripe paint is here. So I'll just select this and I'll apply this to this face. Suppose, and I'll do done. So this new material would also be updated here in the wall material takeoff. So this parking stripe that I just made over here is also here. So all the materials, all the paint and everything is available. So all the area of that, suppose the area of that was for 6 meters square. So that area is also calculated through this. So from here, all the material takeoffs can be generated easily, right? So that is the major difference that you'll see between the schedules and the material takeoff. This would help you in generating the schedules of any wall. Suppose for the construction part, you want to see the volume, or you want to calculate the area, or you just want the width. So for that purpose, you can use the wall schedule. And for the wall material takeoff, you can like differently take different materials from here. You can even rename it. Suppose I can rename it to wooden partition. So this would also be updated over here. You can directly change it from here too. You can just right click over here, go to rename, and you can rename it from here too. So like this, you can change the name of the materials or the uh, schedule that you have created. Apart from that, if we go to 3D now again, there I'll just close this section box. So we have this model. In this, we have like two floors. So there are columns from NGL to the first floor, then you to the first floor to the terrace. So you can also create a graphical column schedule from this. So if I just go over here, right click over here and click on new graphical column schedule. So a column schedule would be generated directly. So it shows up to what level which column is going. So this would also help you in justifying each and every column. So I'll again go to the structural column schedule. Now you have the volume of the column. This now we'll get into a little advanced part of this. Suppose you want to calculate the volume of concrete from here. You want to calculate the volume of cement, sand, or aggregate. So that also can be easily done. For that, you need to apply different formulas over here. And through those formulas, you can directly generate the total volume of cement or the sand or the aggregate. So for that, I'll just open like remove all the filter part, remove the filters. I'll do none and okay. So that I get all the columns over here. So the total volume here is 4.79 meters cube. Uh, this is the volume of wet concrete. If like you people understand, this is the total volume of the column. So a lot of water is also used. So this is the total volume of the wet concrete. In that, we first need to like generate the volume of dry concrete. So we'll go to the fields part, and from here you can add a calculated value or a different formula from here. So I'll just calculate the volume of dry concrete. So I'll just take an average of 50% water in this. So that would be good. So I'll just take volume, and I'll take volume from here and I'll divide it by 0.5, so that we calculate the value of dry concrete. The volume of dry concrete would be here. This would be half of this value. Sorry, I had to do into 0.5. So I can like just go to this and I can edit it from here. So you can't edit the discipline and the type, you can just edit the formula. So for the multiply option, you use the asterisk option from here. So this would be half of this value. The volume of dry concrete would be half of this value. After that, you also need to calculate the volume of cement, sand, and aggregate. For that, again, you need different formulas. So just give me a minute. Okay, so we'll take out the quantity through, suppose we can suppose the concrete here would be M25. So the ratio for M25 would be 1:1:2. So in that, one part is cement, one part is sand, and two parts are aggregate. So if I just explain, suppose there is a volume of 100 meters cube. In that, if we divide it into four parts, it would be 25 meters cube for each. So in that, now one part is cement, one part is sand, and two parts are concrete. That means 25% is cement, 25% is sand, and then the remaining 50% is concrete. The remaining 50% is aggregate. So according to that, we can calculate the volume of cement and different other materials from here. So we'll just go to fields again. I'll create another formula and I'll write volume of cement. So for the volume of cement, I'll again take the type as volume, and I'll go to volume of dry concrete, and I'll now multiply it by 0.25. Since it is 25% cement, so I'm multiplying it by 0.25. Dry volume of cement would be calculated. And I'll do okay. So this is the total value of cement over here. Now, if you want to calculate the total of the cement, you can just directly go to the formatting option. And from the formatting option, you can just take the volume of cement and you can go to calculate total. So this is the total volume of cement that is required over here. Now, if you know the volume of one cement bag, suppose if we see what the volume of one cement bag is, let me just see. So volume of one cement bag is 0.035 cubic meters. So from that, we can also calculate the number of cement bags required for this. So again, you can go to fields, create another formula for number of cement bags. Now I'll just take the volume, and no, I'll take the number this time, and I'll take the volume of cement and I'll divide it by 0.035. Okay. So these are the number of cement bags that you might require to like make these number of columns. So again, you can go to the formatting option, calculate the totals. Okay. So you can also round off this total according to you. So this is like 17.11. So if you want this to be just as 17, you need to remove the decimal places. So you can directly just go to this option, select the column. You have the format unit option over here. This you'll also get from the formatting part, the conditional format. If you go, so you'll get this from here also. You can go to the format unit option, and this right now is using the default settings. So instead of the default settings, I'll use the fixed ones. So for fixed, I need 0 decimal places, or I can just take 2 decimal places, and I'll do OK. So it will just show 2 decimal places and it will round off accordingly. So it now is just 17.12 cement bags are required to fill these number of columns. Like this, you can also like calculate aggregate and sand. So let's just do that too. So I'll just calculate the volume of sand. The volume of sand is equal to the volume of cement since it is 0.25 for both. So I can just take the volume and volume of cement. Okay. And I can just do OK over here. So volume of cement and volume of sand are equal. So it is same. Fine. Again, if you want to calculate the volume of aggregate, that also can be done. Again, you can create a formula. I'll take the volume of dry concrete and I'll multiply it by 0.5. Since this 50% is the aggregate, so I'll just do it 0.5 and I'll do OK. So now this is the volume of aggregate, volume of sand, volume of cement, and also you've got the number of cement bags. You can now calculate the totals for each. Volume of sand and volume of aggregate, I want the calculate totals for each. So I'll just select calculate totals and OK. So this is the entire purpose of these schedules that we want to generate, so that we can generate different elements from this directly. Likewise, you can apply different formulas to different elements. It's not just for cement, concrete, or anything. You can apply different formulas anywhere in your model and create a quantity for that easily. So that is all from the schedules and quantities part today. Now I'll hand over it to Varipam so that he can take forward with the Dynamo how you can link these schedules to the Excel and link Excel to Revit easily, because these are the schedules that will also be required in Excel. These schedules won't like work, like you can just take it to the sheet here in Revit, but for Excel you want to generate a BOQ or anything, so for that you need to link it to Excel. So that will now be explained how you can link directly through Dynamo to Excel. Dynamo is also a part of Revit, or it's a software here in Revit only. So he'll take things forward now. Over to Varun. Thank you.
Hello, everyone. My voice is audible. So, my name is Varipam Biswarjit, and I'm also a BIM Specialist Architecture in the Crappy Code. So, today we are discussing about quantity takeoff. So, This is the we have to Excel. We have to export any quantities, any data from Revit to Excel. So with the help of Dynamo is also another software, but it also is part of the Revit after 2020. Before 2020, we have to install in different things and we have to plug in as a work as a plugin. So that in after 2020, the Revit acquired that Dynamo and insert or in part of the installation part of the Revit. So see, Dynamo is also some platform that we have to graphically or we have to script some kind of languages, so we can have to transfer or data from Revit to Excel. So there is in Revit there is no other option for any labeling, any extraction. So you can save in in the Excel or text format or a CSV file as well, so that there is no any labeling over there. So with the help of Dynamo, we have making some script in here, and then we have to extract data from Revit to Excel. This is you have to uh, get information all the what you have make in the Excel Revit. So let me show you. So we are doing this small project. So uh, after firstly, this is the project. So there is some panels here. Uh, see, there's in the manage tab, we have to go to the manage tab in the Revit panel. So we find the Dynamo. So we have to open it. So it will take some time. So first on often, so that after that open the Dynamo phase. So there is three part that we have to you have to open or you have to you have to make new things. But I have already have the Excel the script, so I will show you the sort in terms of how to how to link that data from Revit to Excel. So I have to open it, export to Excel. So this is the some kind of script that we have get from extracting data from. So there is we have to take the all the wall materials, wall elements of the wall, so that these projects. So in the with the help of the Dynamo, uh, it's little bit dots. Okay. So I've choose this wall type here. There's all categories here. So I take the only wall type here. So there is all the categories in the Revit. So you can select any of this, but I have example as a wall. So I have take this wall and this is the part of the Excel, how to import the Excel. So this I have to run this script. So this is the information that we have got after this, and you have I have only 2-3 parameters here, and you can get all the parameters from this wall type. What is the length, what is the area, and things. And after that, we have to do it as a automatic. So we have to complete it, run it automatically. So here is that I have to add some wall here. So you have to see how to link that. See, there is the wall type is something 77 wall type. So after that, see, I have to add some wall here. I could go to the walls. Yes, I have to pick some 300 concrete wall. So I have to add 2-3 walls here. See, I've added this 4 walls here. After that, see, there is the something I running the script. See, this is the 4 walls have to add here according to all the details here, area, volume, and there's the 80 types comes up after this. I have to delete one, and there is also one minus. So there is the already 77. So this is the live link. If I put there in the added some walls, so it will show automatically in the Excel. So after that, and here there is also the vice versa, that we have to data was if I have to put in the some comment or something to in the Excel, and I have to reflect it, how can I reflect it in that schedule, in that quantities schedule in the Revit model. So that also possible. So that is this is the this is that was the another different script, and this is the another script. So I have to play it like this. I made some comments here after this any this example of this comment. So I've add some comments here, and in this any types I add uh, some comments here. Let's says add more windows, or I let us say different things. Change the plaster thickness or plaster types, and after that I have to minimize it so I can show you simultaneously in the Excel and the Revit. So I take some new schedules here. So I take in the some data here, families and the types, and some type of comments here. I add a comment on that Excel. So after this, there is some comings blank cut. There is no after that we have to open the Dynamo here. Go to the manage tab, and I open the Dynamo here, and I already have I made the script, so I have to open that script again. Import from Excel script. Yeah, this is the different script. So this is the data from script. This is the feed to the Revit data. So I have to freeze it because I have to check first that the comment section was come up in the list management or not. So I have to run it. After see this, there is the what's note, and see I have there is the comment sections here. So there is the all I have to take out the volume or something. And after that, I have to check the other things also. Yeah, it's okay. And I have to unfreeze this. Then I have to run it manually, and I have to run it. See, there is the shown what I am written in the Excel. Add more windows or change plus the type. And if my Excel was little bit hanged. See, this is the cluster. I will make it. See how to. I can show you now how to live link after this was the after showing this running Dynamo script. It was already run in background also. That's why I'm adding some add here some cluster type also, and also adding some change changes finishes. Then you have to save the file. After that, you have to show it in the Revit also. Firstly, after writing or anything, you have to written in the comment section or to add any information. You have to save it first, your Excel, and then you have to the Dynamo knows that the file was saved, and it have to further proceed, and you have to with the help of Dynamo's script, and that our data's input data was reflected on the Revit quantities. So, and also adding some other column here. Suppose I have to write check some classes, and I have to copy it in another. I'm just showing you the some example. See, I have to save it first. After that, see in the Revit also, we have to show the result of the live link with Revit and the Excel. So this is the very easy way to after that there is many you have to take out many information about the quantities. Quantity is also the one of the major role for the project. So you have to take out all the courses or on anything, so that we have to extract or if we have to do something given or submit something. So I want you want in the Excel, so that how to do it. This is the one of the this is the way to do the Excel, how to get the Excel exact format, exact sent into the Excel to the Revit. Or also the vice versa, and if you put in the some comment section or some add some datas, not only comment only datas or anything, so it will affect it on the Revit also. So with the help of Dynamo, and if you want in further details about this Dynamo or something, you have to contact me, contact the later also. You have to and I will over to the Pranami.
Okay, Viswajit, thank you so much for showing us the live link between Dynamo and Revit. So, before moving forward to the Q&A, so let me just share my screen. I would like to give you a brief about two program details that we have here in Capricorn. So, just give me a minute. Okay, so first is the BIM for design. So BIM for design is mainly for architects, civil engineers, interior designers. So for the individual professions, and also students that are there in their final year, they can also come up for the BIM for design. So mostly it's a minimum of 3 months course. So timings are also very flexible. After office timing, we do it, or mostly in weekend also. So in BIM for design, so whoever is interested in learning the BIM, so they can opt for this course. So we teach each and every software tool that is needed for this. So we will be giving you a live project, or if you have your own project also, you can work on that. So even from the Revit basics to the advanced level, we will be teaching you here. Then again, other tools that we'll be needing here are the Navisworks for your class detections, and also even Dynamo also. This whatever you have seen today here, the live link and everything, how to take out the quantity takeoff and material takeoff and everything. So we show you everything in detail so that you can create that in your project. So this is for the BIM for design course, and also we recommend the individuals to different multiple job offers also. So if you want any more details for this, please feel free to contact us. And if you have any questions regarding this, so I'll be happy to help you in the Q&A also. So this is for the BIM for design, and one another course that we have is the BIM Guru. So BIM Guru is generally for the architectural firms, structural firms. So it is like contractual basis for a minimum period of 1 year. So any office that is planning to turn into BIM or already in BIM and they want to proceed it to the higher level also. So will be helping them. So according to the customization, any Revit families also if you are making, so we'll be training their employees to from the basic to the advanced level also, or if they're in the intermediate stage also, we'll be customizing and helping them train to the advanced level also. So most four things that we do here is the training of the employees. Accordingly, it will be per user. Then and the firms that are doing their own project also will be helping them achieve their own project also. So we'll be doing some troubleshooting of their project. Then we will be even helping them to make the Revit families also. So according to the projects that the farms get, we'll be helping basis on that. So any questions regarding this, so you can contact us. Okay, so moving forward to the Q&A. So yeah. So we have got a question here. Can we import all of these schedules in MS Office? Yes, Vatsal and Varapam, if you could answer this.
Yeah, it was very using the Dynamo with the help of the script, and you can import all the schedules in to the MS Office.
Okay. Uh, okay, so we have got another question here. Uh, i- is it an another way, is there another way to link Excel in schedule without Dynamo? I mean, with the help of PY Revit or any other extension?
I think that there is another, it is no another option, but if you have the option, but you have to lose some data or something, you didn't get proper, I think proper data, so I don't think so.
Okay. So, okay, and before ending this, I'll just wait for 1-2 minutes more so that you can type your questions and we'll be happy to help answering them. So let's wait for 1-2 minutes so that you can type the questions. Okay, so please write the questions in the Q&A instead of like raising the hand. Okay. So no other questions then? Okay. So then we'll be ending this session today then. Just give me a minute. Okay, so I think we are getting two more questions. By how to calculate the cement bag quantity? Yes, Vatsal, if you could reply to this.
Okay, so for calculating the cement bag quantities, you need to like create formulas for that, different formulas for that. So as I did in my like model, I made formulas. The calculation for the concrete is the wet concrete. You have to like subdivide it into the dry concrete, and then from dry concrete, according to the ratio that you're using for the cement, sand, and aggregate, you then have to further divide it into the cement quantity. For the cement bag, particularly, you get the first you get the volume of the total cement in that. For the cement bag, you need to know the volume of one cement bag. Usually it's a 50 kg cement bag. So online you can get the quantity of one cement bag. As I saw, it was 0.035 meters cube. So you can divide the total quantity of cement by that 0.035, and then you'll get the number of cement bags in that. Okay, so for the formula, it's just basic mathematics. You'll have to do it that way. Suppose for the concrete, as I said, it's M25. So the ratio for M25 is 1 is to 1 is to 2. So in that, it is 25% cement, 25% sand, and 50% aggregate. So according to that, you have to calculate the different quantities of everything and then further subdivide it for the different like forms if you want to know the quantity of cement bags. So you'll have to like apply these formulas for that. You have to divide it or multiply it, whatever it might be the case in that scenario.
Okay, so any more question, please feel free to write in the Q&A. Okay, we have one more question at the end. Vatsal, can you just answer the last question that we have?
Okay, so for M30, again, you need to know the ratios first. So let me just see what the ratio for M30 is. Just a minute. So for M30, again, you need to know the ratio, and you then need to further divide it. So for the ratio for M30 is 1 is to 2.23 is to 2.12. Now, suppose you have 100 meter cube volume, then you have to further see how much is applying to every part of that, how much is one, how much is like add all three of them and then divide it by 100. So you get the volume of one and then further multiply it by 2.23 or whatever it is. So that way you can calculate it for different like ratios, and it can be done easily.
Okay, so uh, we have answered the question. So if you have any other, let's wait for like 1 minute more so that you can type your questions and we could answer it. So okay, then so we'll be ending the session then. So before it, I would like to thank each and every attendees here for joining us here for this online workshop. I hope it was insightful for all so that you could understand how it is automatically generated. The quantity takeoff is automatically generated in Revit, right? So, and also I would like to thank Varappam and Mr. Vatsal here. So thank you for taking us through. So I hope it was helpful for all here. So thank you everyone, and we'll be ending the online workshop now. Thank you.